Imagine finding a doorway in space, stepping through it, and emerging somewhere completely unknown. Not just another planet, not just another galaxy, but perhaps another universe entirely. The biggest question about wormholes isn't how they work. It's what might be waiting on the other side. Before we start, make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss any future deep space mysteries. When scientists talk about wormholes, they're describing theoretical tunnels through space-time predicted by the equations of general relativity. The theory created by Albert Einstein, according to this framework, space and time are not rigid structures, but flexible, capable of bending, stretching, and possibly connecting distant regions. If a wormhole exists, it would have two openings, often called mouths, connected by a throat. One mouth could be near Earth, while the other might be millions or billions of light years away. So, the simplest answer to what lies on the other side of a wormhole is another location in our universe. But that answer is only the beginning. One possibility is that a wormhole connects to distant points within the same galaxy. Imagine traveling from Earth to the center of the Milky Way instantly instead of taking tens of thousands of years. From a physics perspective, this is one of the least exotic scenarios. The wormhole acts like a shortcut, compressing distance without requiring faster-than-light travel. To someone passing through, the journey might feel almost instantaneous, while outside observers would see nothing more than someone entering one opening and exiting the other. But wormholes might not be limited to connecting points within a single galaxy. They could potentially link entirely different galaxies across the observable universe. The scale of this is almost impossible to comprehend. Our universe contains hundreds of billions of galaxies, each with hundreds of billions of stars. If wormholes could connect arbitrary points, then the other side might be anywhere, from a neighboring star system to the farthest reaches of cosmic space. There is also the possibility that the other side is not just somewhere else in space, but somewhere else in time. Because space-time combines space and time into a single structure, a wormhole connecting to regions with different time flows could allow travel into the past or future. This happens because time moves differently under different gravitational conditions or speeds, as predicted by relativity. If one mouth of a wormhole experienced time dilation compared to the other, someone entering could exit at a different point in history. That means the other side might not just be another place, but another era. This raises enormous philosophical and scientific questions. If someone emerged from a wormhole into the past, could they change events? Would paradoxes occur? Physicist Stephen Hawking famously suggested that the laws of physics might prevent such situations through what he called chronology protection, meaning the universe somehow stops time travel from becoming possible. If that's true, then perhaps wormholes that lead into the past simply cannot exist or would collapse before anyone could use them. Another intriguing possibility is that the other side of a wormhole could lead to a completely different universe. Some cosmological theories propose the existence of multiple universes, often called the multiverse. In certain models, wormholes might connect these separate universes like bridges between bubbles in a cosmic foam. If that were the case, stepping through a wormhole might take you somewhere governed by entirely different physical laws. Gravity might behave differently, particles might have different masses, or the structure of matter itself could change. In extreme scenarios, you might not even survive crossing into such a universe because your atoms depend on the physical constants of our own. The idea of wormholes connecting universes has fascinated scientists and science fiction writers alike. In fact, author Carl Sagan once consulted with physicists while writing his novel Contact to ensure the concept was scientifically plausible. Later, physicist Kip Thorne expanded research into traversable wormholes, partly inspired by storytelling questions about interstellar travel. This collaboration between science and imagination shows how exploring the unknown often begins with asking what might be on the other side. There is also the possibility that the other side of a wormhole leads somewhere dangerous or destructive. Wormholes would likely form in regions with extreme gravitational conditions, possibly near black holes or other exotic cosmic phenomena. Emerging near such environments could expose travelers to intense radiation, tidal forces, or unstable space-time distortions. Even if the wormhole itself were stable, the destination might not be safe. You might arrive in the middle of interstellar space, far from any star, or inside a region filled with high-energy particles that could instantly destroy a spacecraft. Some theories suggest wormholes could connect to black holes themselves. Black holes are regions where gravity becomes so strong that nothing, not even light, can escape once it passes the event horizon. In certain mathematical solutions, a black hole might connect to another region of spacetime through a structure similar to a wormhole. However, most physicists believe real black holes do not allow safe passage because anything entering would be crushed by extreme gravitational forces before reaching any exit. Still, the idea remains a topic of theoretical exploration, especially when quantum effects are considered. Another fascinating concept is that wormholes might not lead to large destinations at all. Instead, they could connect to microscopic scales. Some speculative physics suggests space-time at extremely tiny scales might contain constantly forming and disappearing wormholes, sometimes called quantum foam. If technology could somehow access and enlarge one of these microscopic connections, the other side might initially be unimaginably small before expansion. This idea is far beyond current science, but demonstrates how wormholes challenge our understanding of size and scale. There is also a philosophical perspective. The other side of a wormhole might reveal something fundamental about reality itself. Modern theoretical physics increasingly hints that spacetime might not be a basic ingredient of the universe, but something that emerges from deeper quantum processes. Some scientists propose that wormholes and quantum entanglement are related, meaning connections in spacetime could reflect connections in information. If this is true, stepping through a wormhole might not just be traveling somewhere else, but interacting with the underlying structure of reality in ways we don't yet understand. In popular culture, wormholes are often portrayed as gateways to adventure. A famous example appears in the film Interstellar, where astronauts travel through a wormhole near Saturn to reach another galaxy. While fictional, the depiction was based on real physics equations, making it one of the most scientifically grounded portrayals ever created. In that story, the other side leads to habitable worlds and survival opportunities for humanity, reflecting our hopes that cosmic shortcuts might one day save us from extinction. If advanced civilizations exist elsewhere in the universe, they might use wormholes intentionally. Some scientists have even speculated that detecting unusual gravitational signatures could reveal artificial wormholes built by intelligent beings. If humanity ever encountered one, stepping through could mean meeting entirely new forms of life, or discovering technology far beyond our own. The other side might not just be a location, but a doorway into a broader cosmic community. Of course, there is also the possibility that wormholes simply cannot exist in a usable form. While general relativity allows them mathematically, maintaining a stable wormhole would likely require exotic matter with negative energy density, something we have never produced in large quantities. Quantum effects might destabilize them instantly. Unknown laws of physics could forbid them altogether. If that's the case, then the question of what lies on the other side becomes purely theoretical, a thought experiment rather than a future destination. Yet, even as a thought experiment, it is powerful. Asking what lies on the other side forces us to confront the limits of knowledge. It reminds us that our universe may be far more connected and strange than our everyday experiences suggest. Distances that seem impossible might be shortcuts waiting to be discovered. Time itself might be navigable under the right conditions. Entire universes might exist beyond our cosmic horizon. If humanity ever does find or create a wormhole, the first journey through it would be one of the most significant moments in history. The traveler would become the first being to cross a bridge in spacetime, entering the ultimate unknown. On the other side could be a distant star, another galaxy, another time, another universe, or something we cannot even imagine yet. That uncertainty is what makes wormholes so fascinating. They represent both possibility and mystery. The idea that reality might contain hidden doors we have not yet learned to open. And maybe the most profound answer to what lies on the other side of a wormhole is this: it lies beyond the boundary of current human knowledge. It represents discovery itself. Whatever is there would expand our understanding of physics, existence, and our place in the cosmos. If you enjoyed exploring this mystery, don't forget to like the video, subscribe to the channel, and turn on the notification bell so you never miss another journey into the unknown. Thanks for watching, and see you in the next video.